Well, good morning, everyone. How are you doing? Do you like the first frosty morning?
Very good.
Let's see. Uh, Start to minutes down real fast. So let's see. Zoe the Great, Mercator the Great, and Arturo the Great. Perfect. Today we're learning about something super crucial. One of the most important things you'll probably learn about in computers, and one of the most critical, and it's called regular expressions. So regular expressions is the word they use for it. And the way that there's a link that I put into the Moodle shell to a regular expression runner that I made more than 20 years ago, way back a long time ago, and it still works. So it's called glob execute, except nowadays they just call it regular expression though. So um, you put the regular expression into the middle box and you put some text in the first box, and then it finds the result of the regular expression and puts it into the third box. So let me just explain the syntax of regular expressions to you. First of all, you start with the slash, and then you put whatever you want to match into the middle of the slash, like this. And then you put the end of the slash like that. Now with the forward slash, just like a directory delimiter. And then you put modifiers after the slash. So like if you want it to be global, you put G afterwards. If you want it to be insensitive, you put I afterwards, etc. There's more flags you can use as well for specialized cases. So what do you think the result will be of the expression slash moon slash GI? What matches do you think will be found from that input? What matches do you think will be found? Let's try it and see. It'll find the word moon. See that word moon right there? What if I tried to search for a word that's not there? Like think of a word that's not there.
Blue.
Blue. So if I search for the word blue, it doesn't find anything. Now, if I put the word blue into it like this, I'll have a, hold on, this keyboard is kind of crooked. I'll have a blue Christmas. Now it'll find the word blue. What about if I say um, blue Spanish eyes is a song let me see if I remember who's saying it. Humper Ingerl is a song that Ing, so I don't remember what his first name was. Humperdinck sang, I think. Engelbert, I think. Engelbert Humpel. I don't know how to spell Engelbert. Engelbert Humperdinck. Now, if I take away the I from that regular expression, it'll still only find the small blue. So make sure that you're remembering this. If I put an I after it, it'll find both the small blue and the capital blue. See that? So it'll find just a blue if only the lowercase one. It'll find the capital one too if I put insensitive after the regular expression. So somebody tell me a regular expression to find all the lettered I's in this entire paragraph. So what should I start with? If I want a regular expression to find all the letter I's in that entire paragraph. Forward slash I. Mm-hmm. GI. Right. Global means find all of them, and I means insensitive. So if I run that, it'll find, well, there's a lot more I's than I even realized were there. So if I'm that I, it found this I, which is capital. It found this I. It found this I. And it found this I. So there it found all those different I's. Is there any way to find, let's say if I wanted, instead of just finding the word moon, let's go back to the word moon. What if I wanted to find not only the word moon, but whatever punctuation was after the word moon? So what punctuation comes after the word moon right now? So if I put a comma in that and I did run, then it'd find the comma as well. But what if it was a period though? Like what if it was like this? And I went to the moon, and then instead of saying on and on the other side, I just said on the other side, he found a bone. Now it won't find the word moon or the comma. So what's the problem there? Because there's no comma there, but what if I wanted it to match both a comma or a period, any punctuation? Except what if I didn't even know for sure? It could be like any punctuation at all. Anything that's not a letter. In fact, it could be, what if you wanted to match actually moon or moons? So like this, moon or moons. If I just said moon, it'd only find the word moon, even though it's really the word moons. See that? So what if I wanted it to find, so first let's go back to punctuation. If I wanted to find the word, let me just erase this. If I wanted to find the word moon or moon or moon, exclamation point, and to match the punctuation after the word moon, I could put a period there. Period, even though it's only the word period, it's actually automatically expanded by regular expressions. They have it programmed into the definition of them. So period will match anything that comes next, not just a period. So I forgot that a global flag, by the way. So it didn't match the other two. But if I put the global flag, it'll find all matches. Now it'll find moon, period, moon, question mark, and moon, exclamation point. And it will also find moons too, as well.
Would it do that if you got rid of the period in that moon with the expression?
Well, if I got rid of the period, all it would find is just moon, 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 moon. It wouldn't even find what was after the word moon. So right now we're focused on trying to find what comes after it so that we don't just cut out part of the word and just have the word moon for all of them.
Could you put any one of those in there and still do that? Or is it just?
No, it's just period. So like if I just said exclamation point, it's only going to find that one.
What if you only want to find period?
Well, then if you want to, that's actually a good question. You can put a backslash before the period, then it means it's a literal period, and then it'll only find the period. It won't find the exclamation point or anything. Yep. Now here's a question though. What if it says moons period, and you want it to match the whole word moon or the word moons, and you want it to get the punctuation at the end?
Or
So if I put this before, now it's only going to find the moons and the period. It won't find any of the other ones down because the other ones don't have moons. So there's two ways of doing it. We could say moon S question mark. That means that plural S is optional. Now it finds moon period, moon question mark, moon exclamation point, and moons period. So that's kind of a cool way of doing it. So that finds any word moon followed by whatever possible punctuation. But now what if we wanted to find it not only with the end of a sentence with the punctuation, but maybe in the middle of a sentence, like I like the nice moon today. So that will not, well, maybe it did actually. Yeah, so actually it did because the word period actually matches even a space. So notice that, look, if I put the cursor into that box, you can see there's a space after that word moon. So that actually matched the word space after that. But if I didn't have anything after it though, then it wouldn't match it though. So you could also put a question mark after the period if you wanted to. But then if you put a question mark after the period, then it wouldn't match any of the other periods. Watch what happens. Well, maybe it does actually. I guess it does. but the period, but if whatever comes next is optional, so it doesn't necessarily have to match the extra character there. Let's see. How would we match all the words in all the words? That's a critical question. Like, let's just say if I had a paragraph like this, how would I match all the words, not just a certain word? How could you write a regular expression to match all the words, not just a certain word? So if I said like page, G, it's gonna find the word page, not the other words though. What could I do to find any word? So first of all, we need a backslash character to represent a certain character class. And the character class, there's several character classes. The one that represents words is a W. So if we say backslash W, that represents actually any letter that could be part of a regular word. It includes letters, numbers, and underscores, but not hyphens though, because hyphens are considered punctuation. So backslash W, now this is going to be a lot of results. Okay, watch this. It finds pages full of results, but it only finds one letter at a time. So what if you wanted not just a letter, but the whole word though, to be found? Then you say a plus. Backslash W plus means find one or more letters that come from words and then group them all together into a single match. So backslash W plus, that regular expression finds the full word. That regular expression finds the full word. No phones or anything else during class. Okay, so now let's just go ahead and try to find. Let's try to think of any other possible questions we could try to find from text. So look through that text. How could I find something, either a specific word or a specific group of words or a sentence maybe? How do you think you could find a sentence from the text? What do you think you could do to find a sentence?
Putting a number in that statement there, like
Putting a number?
how code does, like line 1, line 2, line 3.
Well, in order to match line 1, so first of all, how do you define a line? What's a line exactly? In a regular expression, how do you define a line? So a line ends with, technically, it depends on what system you're on. Windows is the worst. It has carriage returns and line feeds at the end of every line. Carriage returns aren't necessary because we don't use typewriters anymore. But if you put on something like this, plus it also makes it impossible to actually to define a line accurately because of the carriage returns. But if you ignore the carriage return and you say anything that's not a line feed like that, by the way, okay, but we can't get to that point. Yeah, we're not to that point yet. First, I have to teach you about character classes. So let me delete all this. What if you had the word color and the word color like that? In Britain, England, they use a U after it. And then what if you had some words that were spelled differently, like Lady Gray or Lady Gray, like that? So how would I match, first of all, both the word color and the word color or color? It's probably pronounced the same way. How would I match either color or color with a U in it? So color by itself just gives color. Somebody who's been watching closely, tell me what to add to the regular expression so it matches both color and color with a U in it.
You can do the U with a question mark.
Yep, put a U there and then do a question mark. So that matches a U if it's there, but if it's not there, it's optional. That's what the question mark means. Then it finds them both. Okay, now
You want to do that, not do that.
what?
Just mark the other side of the R.
Then the R would be optional. So if I did that, it's only going to find the color. So you have to put out the letter that you want to be optional. Now, how could I get it to find the word color or the word gray? Both. So let's backspace that color, put in vertical bar, that means or, and then say gray, like that. Now it finds color or gray. Both of them will match. But now it doesn't have the U. So let's go ahead and put the letter U into the color, and now it can match color, or gray. But then how do you make it match the word gray or gray with an E? It only matches the spelling right now with Gray. How do you make the regular expression match Grey and Gray? So there's an easy way of doing it, but I don't want the easy way, I want the hard way. Easy way of doing it is to say or Grey, like that. That would match them both. But you can't put in, that would take forever to put in every different spelling of everything with the or, and it would also take a long time to run. First it has to run through that first match and then fail, then move to the second possibility and then try that one and then keep on trying. So the better way of doing it is to replace, now we can't just say a question mark, that won't work because there's never an E in it. So making the A optional doesn't help. Instead, you need to put a bracket and then AE in the bracket. That is called a character class. G that accepts either or any letters from the set A and E. There could be GRAY or GREY. Then when you run that, it matches gray and gray, like that. So learning how to match text like this is super crucial. And I remember last time you said not very many of you knew what regular expressions were. So this is this in discrete math, they talk about finite state machines, and this is an example of one of those. So there's basically finitely many combinations that we're trying to. Now the why it's called a machine is a little bit weird, but because they have to like make a machine on the computer that untangles all of this. But this is how it works. Now look how complicated that looks. Doesn't that look like rocket science? A little bit. So regular expressions are not scary to actually do, but once you're finished with them and giving it exactly what you want, the result almost always looks scary. So it's important to be able to break them down. Like if I saw this regular expression, the first thing I realize is the word or. I realize it's just talking about either this or this, and then I can forget about that part, and then I could say it's the word color or the word color. And then this is the word gray or the word gray. Well, don't know how to distinguish between the pronunciation, but the word like gray or the word gree, but they're really not pronounced gree, but so it matches all four of those words. Now let's talk about sentences. So you have to, or paragraphs. So what if you wanted to match a full sentence, for instance, or a full paragraph? Actually, let's start with paragraph. How can I match this entire paragraph as a match? So first of all, at the end of each paragraph is a line break. So the end of the paragraph is going to have a line break, or a line feed, which is called \n. It's called a new line character. Now it exists on the computer as just a button that you push. When you push it on the keyboard, it's called the return key. So it's the end of the home row on the right side is like the return key. Now Windows computers silently insert a carriage return before every line feed, and then they delete it when they show you the text again. So it's like an invisible throwback to like when they had typewriters a long time ago. So let's try this. Let's try putting dot and then /r/n. See what we get. We get nothing actually. Okay, actually that's kind of cool. Let's just try \r/n. Now, do you notice that we're getting nothing? But look, well, I guess we are getting nothing. Let's take with us carriage return. I think actually the carriage return might be getting deleted. Even though we're on a Windows computer, it might be getting deleted because since it's not part of the standard, it maybe is just getting silently deleted so that we don't have to worry about the carriage returns. Let's try running it now. Now we have some, now it doesn't look like we're getting anything now, but we really are. Though look in that box, it's not empty. See, there's several lines in that box. If I delete those lines and I run it again, look, those lines are there again. See, there's like two or three blank lines in that box. That's because it's actually matching the line feed at the end of the first line, and then another line feed, and then another line feed, and then another line feed. So it's creating 4 blank lines. What if I wanted to get the punctuation or whatever is at the end of the line? Then I could do period \n. Now it gets the period, the end of the first line, but it doesn't get anything else. That's interesting. Let's try doing, how about let's do period star \n. See what that does. That gives us the entire first paragraph. Okay, that gives us the entire first paragraph. That gives us the entire first paragraph. Now I'm wondering why it doesn't give us a second paragraph. Let me try something. Let me put an S at the end of that. Still doesn't work. I think, I think I might have programmed it so it wouldn't accept multiple lines back a long time ago. But theoretically, if you run a regular expression against the full text, the entire both paragraphs in that thing, it should actually find the second paragraph as well. Might have to go back and check why it's not doing that though. Okay, let's try to see if we can match a sentence. So this is the first sentence right here. This is the second sentence right there. What do you think we could do to match a sentence? So instead of just matching the full paragraph, it'd match just the sentences. What could we do? What could we do to match just each sentence? So first of all, by the way, look at the period star. Period means any character except the period does not include things like line breaks usually, unless you put the S flag, which treats everything as a single string, which I had tried earlier to try to see if I could match both paragraphs. But the period character, if you say period star, that matches anything and everything except for line breaks. So if I run that, it's going to find everything. But what if I just want to say period star and then an actual period? That's still going to find the full paragraph. Do you know why? Well, because for one thing, the period at the end is not escaped. So let me say period slash \/ period. It's still going to find everything though. I know, what do I need to do to that period star so that it only matches up to the first period instead of the last period? Well, by default, the star is greedy, and they talk about this in the textbook. The star is called a greedy algorithm. It does as much as it can before it stops. If you want it to not be greedy, you need to put a question mark after it. So it'll do as much as it can, but only until the thing after it can find a match. So if we say period star question mark and then \/ period, that's going to find, that's now going to only match until the end of the first sentence, and then it'll stop. And then it'll start right away until the beginning into the next sentence. Now notice the first match starts with the word this. The second match starts with a space. Why does the second match start with a space?
Because the first one cuts off right at the period.
Because the first match cuts off right at the period. Cuts off exactly at the period. So the second match begins with the space that is after the period. It doesn't begin really at the beginning of the next sentence. What could I do? What could I add to the regular expression so that the next match would actually start with the word all instead of including the space in between the sentences? I could put a \B there. That's called the bare word instruction. That means the match is not allowed to start until it gets to the beginning of a word or the end of a word. So anything that's the beginning or end of a word, that's matches what's called the bare word delimiter. Now it will not start at the space. It'll only start doing the period star question mark with the word all. So \bare word period star question mark \period G matches both of those sentences exactly. But what if I added a question though? Is this cool? Question. It would not find that sentence. Can anybody explain why it does not find that sentence? Right, because a question mark. Now, if I just put a period to match a question mark or a period, it won't work anymore. It'll match everything now, right? In fact, actually, this actually matches only one letter at a time. Can anybody explain why it matches only one letter at a time now? Just by taking away the backslash before the period, why does that match only one letter at a time now? Because remember, we have the question mark after the star, so it matches anything, but only as much as necessary to find the next character in that regular expression. But the period in the regular expression now represents anything, because a period without a backslash doesn't mean a literal period, it means any character. So that means the first match only needs to find almost nothing and then find one more character, which could be any character. So it only finds one character and then like a spacer or whatever. So if I put the backslash back in front of the period, now it only matches the literal period, but that takes us back to the place where we were before. And we still can't find the question sentence. So can anybody think of something that I've taught you a few minutes ago that would enable us to find the question mark sentence as well as the other sentences that have periods after them? What could I do? So instead of matching just a literal period right there with the backslash period, how could I match a period or a question mark or an exclamation point? How about this? The brackets and then put period, question mark. Let's try that. It worked. And then let's try exclamation point as well. That still worked. We don't have any we didn't have any exclamation points in it, but let's add one though. So it worked. So now it matches all sentences. Except, can anybody think of an issue with that regular expression though? This is why you can't really truly match all sentences in real life with regular expressions, probably. Unless the computer can actually understand the grammar of what's being said, it's really not possible to match all sentences. Why is that? Because what if you have something numerical in them? So like all matches up to 27.5. What if I had a period in the middle of a sentence? Now that ruins everything. All matches up to 27.5 comma, and now it thinks that that's one sentence. And now it thinks this is one sentence. So if you look at some classical books or traditional books like the Bible, for example, the Bible never has any numbers in it like 27.5. It never uses like Roman numerals. It never says like the Bible never says like there were 3 sheep in the fold or whatever. The Bible always says things like words. There were 3 sheep. So if you have a book that never uses numbers in it, then that doesn't matter. But if you do have sentences, which we often do, that have decimals in them, then it won't work. So let's try to think for a while. Is there any other challenge of matching things that you could possibly think of? Is there any other possible challenge of matching things that you can think of? What do you think? What if we wanted to find all decimal numbers in text? So like, what if we actually wanted to find numbers like 27.5 in a sentence? How could we find all numbers from a sentence? So like, let's copy all of this text right here. Let's put this text in this box. Let's try to find all the numbers in it. So what would the regular expression mean to find all numbers that are written with decimals, not with like Arabic numerals like 0 through 9? What could we do?
Bracket 0
Yeah.
through 9.
Yeah. And then G. Now that would find one at a time. So that finds 2750211, finds all of those. So that's cool. Yeah, so it finds a 2, that finds that 2, that 7, that 5, etc. Finds all the decimals in the thing. Now it only finds one of them at a time, what could I add to the regular expression so that it would find not just one of them at a time, but the full number wherever that number was? Let's say, how about 0 through 9 plus? That finds one or more of them, and it's greedy, so it finds as many as possible in a row. So that finds 72, 5, 0, 2. Now see it, that number 72 that's up here, it now finds that. Instead of just finding the 7 and then the 2. But what if we had the 72 formatted like as a negative 72? If we run it, now it's just going to still find 72, even though it's actually negative 72. How do we make it find the negative with a number?
Bracket.
Yep. But now, though, it won't find anything but the negative 72. Smart. Yeah. Now it finds negative 72 on the other ones. But what if it's negative 72.4, though? Now it'll just find negative 72, but then the 4 it thinks is a different number, even though it's not. Do you notice now there's a 4 after the 72 that it found? How can I make it find negative 72, but then also the 0.4 as well? With it?
Putting this putting periods by the numbers, that bracket was doing.
Yeah, so we could put a backslash period, right? And then some more 0 through 9. Now the plus like that. Yeah, so let's try that. But now it only finds just the one that has that. Now it doesn't find the other ones. So watch this. I can wrap this entire thing in a parentheses. Now that includes that in a match. This is called a grouping thing. If I want it to be a non-grouping group, which is a weird thing, I'll put a question mark colon before it. And then I can put after the parentheses, I can put a question mark. So that means that the 0.4 is optional. So now we got negative 72.4 together, and then we have a non-grouping group, and then we have all the other decimals matched afterwards, like that. Okay, perfect, that's awesome. Then, now by the way, why would you want to have a non-grouping group? Because many times in regular expressions, you're trying to construct something to match a certain thing, and that thing is numbered. If you don't put the question mark colon inside the group, it will actually number that and assign that to a certain variable. So you basically use up extra memory, and sometimes it'll even throw off what you're trying to find. So we're not necessarily trying to assign that to a certain variable. So that's why I put the question mark colon before it. Now, if you took the question mark colon away from it, it'd still work just the same. But now the code is doing more inside that we don't necessarily mean for it to do. So I'm going to keep the question mark colon there. But what if it's exponential notation like this? What if it's negative 72.4 times 10 to the negative 30th? How do you write 10 to the negative 30th in scientific notation in paragraph form? Does anybody know how it's written in like computer form? They use the letter E, like E negative 23. Negative, sometimes it's capital E actually. So it might be like negative 72 point, actually, that's not accurate. Scientific notation always has only one decimal before the decimal point. So negative 7.24 E negative 23. That's what they'd use to write it in scientific notation. So how could we add that to it so that it would match the scientific notation E minus 23? Well, we could add another parentheses, question mark colon to make it a non-grouping group. And then actually I shouldn't say non-grouping group, that's stupid. A non-capturing group. It still is a group, but it doesn't capture anything in a variable. So question mark colon, and then I could say E, and then I could say either plus or minus, because it always has to be either one, and then 0 through 9 plus, right? And then that whole thing is optional. So if I run that, oops, my program says that there's an error in it. So just a second. I think I must have forgotten to do the close parentheses maybe. Oh yeah, there we go. I had too many closing parentheses. There we go. Okay, so now when I run it, it matches. So negative 20, it's negative 7.24 e to the negative 23. That actually matches that whole thing like that. Fantastic. And then plus it still matches all the other ones. So let's try adding some more complicated things to the other numbers. What if I said instead of 2, I said 2.7? Like that. Would it still match? Yep, I found 2.7. What if I said instead of 2.7, I said 2.7 e to the power of 9. It doesn't match that though because I forgot to make it insensitive. So what flag makes something insensitive, case insensitive? I. So if I add I, now it'll match. Oh, I forgot. Actually, if it's a positive, you don't have to necessarily say plus before it. But let me go ahead and say plus. So let's actually, instead of how could I make it so that the plus is optional? But the how can I make it so that the plus is optional, but you could put the plus if you wanted to, but the negative would be required. So it could be E9 for E plus 9, or it could be E-9, but it could also just be E plus 9 as well. How can I do that? So what I'm saying is I would like to be able to write E 2.7 times E to the times 10 to the 9th as 2.7 E9 or as 2.7 E plus 9. Either way, how could I let it accept both options? What could I do? So look where I have the E and the plus and the minus. Instead of saying plus and minus, let's put another group in there and say question mark colon, and then say, what should I say? I could do a plus. That would accept a plus sign. Actually, I can't say plus because if it's not inside of brackets, plus actually is plus means one or more. See that plus? That means one or more of those. So the plus actually in that case means one or more colons, which is not what I want it to mean. So let's put it inside of a bracket. So that means a literal plus. So it could be a plus, or it could just be nothing, or it could be a minus. How's that? Would that work? That should work. Okay, perfect. Let's try that. So now let's try changing it to E9 and see if it still matches. Yep, it works. So now it matches 2.7 E to the 9th or 2.7 E plus 9. Let's see if it still matches 2.7 E to the negative 9 as well. Perfect. It matches all three. So now we have a regular expression that matches a lot of different numbers. So who would have thought, and there's probably other numbers that we haven't even thought about. Look how long it is though. Just to get a regular expression that matches some common cases of numbers in text, it looks like this. Isn't that pretty terrible looking? So when you're working with the regular expressions, make sure you start from the smallest, simplest cases and then slowly build them up to consider the other complicated options. Because all we started with, we got from here to here. Let me copy that and put it up here. We started from just this, just 0 through 9. And then we got from that, we got all the way up to this by considering more complicated cases of numbers. So that's kind of cool. Okay, well, any final questions about regular expressions? Any challenges that you can think of that we might both find or anything?
I was wondering what I had, I'm trying to remember it.
I'm still thinking about why we couldn't do the multiple paragraphs. Because theoretically we should be able to. Let me actually download some text from somewhere. I'm going to go to Project Gutenberg, Pride and Prejudice. And I'm going to download the plain text of that, plain text, copy this entire book. How many of you read Pride and Prejudice? Yeah, good job. I've read it like twice probably. But I didn't read it until I was in college though. Okay, so now it has the entire book Pride and Prejudice in there. Now there's gonna be so many matches. First of all, let's see if there's any numbers in it. Yep, there are. Now, most of those numbers are not probably in the book, because actually 1894, maybe that's in the book. But most of the numbers are probably in the like header and stuff like that, like release date, language English, etc. But some of the numbers are in the book though, like 1894, the address of the publisher, things like that. So we found all the numbers in that book that way. How could we find something that's okay? Let's try this. How could we find something that's within a quote? Do you see this quote right there? Loving by allowance. How could we find something that's within a quote? Let's try that. So /, let's copy the beginning of the quote, and then let's copy the end of the quote. What would we put between the quote symbols to find what's between the quote symbols? What would we have to put? So I'll give you two options. Should I put a period star to represent anything as many times as needed to get to the end of the quote? Would that work? You might think it would work, but what that would actually do, period star, and then the end of the quote, that would find everything in the book from the first time a quote symbol happens all the way until the very last quote symbol in the book. So pretty much find the whole book. So what do I need to add after the star to make it find only just what's within the individual quotes? How about a question mark like that? So if I put a question mark there, then it changes from a greedy algorithm to a non-greedy algorithm. It'll only find as much as needed to get to the first closing quotation mark. So if I do that, now I get all the quotes in the book. I get loving with personal love, Mr. Spectator, cynicism, narrow miniature, she is tolerable. A lot of quotes from it. Except wait a second though. Some quotes in the book might be written with older style quotation marks, so they instead of smart quotes. Do you know in the old days they didn't have these like special smart quotes that like go down on one side and up on the other side. They just had regular quotes. Like, what does a regular quote look like? They're just both vertical, and then yeah, so maybe I could replace with the character class and say both vertical or the smart open quotes, and then replace this with the character class with regular ones or the smart ones. The smart ones are kind of easier actually to use because the beginning of the quote is always different from the end of the quote. Although, have you ever been typing in Word and it accidentally puts the wrong kind? Like you're at the end of a quote and it messes up and puts the beginning quote instead. So that's just something that you could do. So it would find either a regular quote or a smart quote. Let me go ahead. So there's tons of things you can do with regular expressions. So let's review a little bit of what we've learned. So what is one thing that we've learned today?
Things in a sentence.
What?
So finding specific things inside of a sentence.
Yeah, finding things in a sentence. Okay, so let me give some names to what we learned. So we've used character classes, like that, like in brackets, right? We've used flags, like G means global, I means insensitive, and GI means global and insensitive. We have used quantifiers like star, plus, and question mark. Star means 0 or more times, plus means at least once. So star means find something 0 or more times, as many as possible. Plus means to find something at least once, 1 or more times, as many as possible. And the question mark means to make it as few as possible. To find a match. So now I don't expect you to remember everything we learned today. I just wanted you to be able to see what regular expressions are and to build at least one complicated thing with them, which we did with numbers. So in order to match all possible numbers, which that wasn't even all possible numbers. Somewhere I've read that it's impossible actually to build a regular expression that truly matches any possible numerical form of a number. But at least we matched a lot of them though. So that's basically all for today. Next time we're going to have another programming little little class, we're going to talk about the code that I have on these 2 pages. So we're going to build, and the reason I had regular expressions today is because this uses regular expressions. We're going to actually take the book Pride and Prejudice, or maybe even some other books. And we're going to use regular expressions to train like a very simple sort of AI system. And then we're going to have the AI thing do some generative AI to like produce some sentences based on what it's learned from the book. So that's what we're going to do next time. And before I let you go, let me catch all the stragglers for attendance. So let me stop the recording.